Hi, this is Mr. Manley. In this video, we're going to look at inequalities, graphing inequalities and finding inequalities that are on a plane, that is on an XY axis. This should be review of something that you've seen since algebra, algebra 2, Precalculus. And there are just a few reminders that I want to address and a couple of points to make. Here I've got an inequality that I want to solve, and when we solve an inequality, the way that we are solving it is by graphing it. It's not like an equation where we can find a single solution. We have to represent a range of solutions, and we're going to represent that graphically. So here I've got an equation or an inequality, and what I always like to do is, if possible, my most direct approach is to find the x and y intercepts of the inequality. That's not always convenient, but I like to at least take a look at that and try to start there. And x and y intercepts, that's x is 0, and that'll give me the y intercept. And that is y is 0, and that will give me the x intercept. And those are just two easy points to find, right? If I let x equal 0, then that zeroes out, and then I've got y is equal to -3. Of course, I'm thinking about the edge of the solution, so I'm thinking of this in terms of an equality at this point, trying to figure out where is the edge of the solution. So I've got y at -3, and then if y is 0, that zeroes out, and I can easily see there that I would divide by -2, and I would get that x is 3/2, or 1.5. And then I want to graph those 2 points, 0, -3, there, and 3/2, 0, that's 1.5, there. And I will draw that line, and that's the edge of my solution. Now, one thing to consider is that this is a greater than, and you should recall that we could also have greater than or equal to. So I could have an equal sign there. If the equal sign is there, I would leave that edge solid. But since the equal sign is not there, I'm going to dash this line here. If I can dash it like so, and then I'll be going up to that edge and not including that edge. The next thing I want to look at is, where are my solutions? I'm going to have a range of solutions that goes along with this inequality. And one way to do it is to think about the point 0, 0. Is the point 0, 0 part of this solution? So I'm going to say that I'm going to check point 0, 0. And if I plug that in, that's just a really easy value to plug in, right? Because this idea of zeroing out the x's and the y's. So if I zero out that x and I zero out that y, and then I'm going to have 0 is greater than -3. 0 is greater than -3. Well, is that true? So I need to know, is that true or false? 0 is greater than -3, so that is true, and that means that it is part of the solution. So this point here, 0, 0, is part of the solution. And then because that single point, that one point is part of the solution, I can say that all the points are part of the solution that are on this side of the edge that we have drawn. And that's our solution. The idea being that if I chose any point over here, if I chose a point there, a point there, a point there, any one of these points, if I plug it in for x and y, I will get a true statement. If I take a point over here, and let's take one. So if I take that point there, and what is that point? That is point 1, 2, 3, and then negative 3 halves. Or yes, negative 3 halves. I wish I would have taken a more convenient point. I guess I could switch it easily enough, but let's go ahead and use it. What would I have? I would have, if I plug in a 3 for x, I'm going to have negative 6, plus, if I plug in a negative 3 for 3 halves for y, and I'll just do that as a minus, that would be minus 3 halves. And then the question is that greater than negative 3? And obviously no. We can look at that and say negative 6 minus 3 halves is definitely not greater than negative 3. Because I'm going to have this, it's going to be more negative. It's going to be to the left of negative 3. So that is not a solution to this inequality. And in fact, the point here is that no point that I select over to the right side here, we'll say, no point that I would select over here would satisfy the inequality. So this is how inequalities work. One comment that I would like to make is this method of checking by using the point 0, 0, we're gonna run into a problem if the equation actually passes through 0, 0. And in that case, then we have to just select some other point. Okay. We are going to move over here to graph the inequality in the coordinate plane. And these are equations, or these are inequalities, I should say, where we have a single variable. And students still get tripped up on this a little bit, but if you just slow down and think about the sense of it, should not be difficult. I think students do realize that this is horizontal or it's vertical, and then sometimes they make the wrong choice. So what I am going to say here is that I've got x is negative 2, so that is clearly putting me here at negative 2, and then my edge is at x equals negative 2, so I'm going to do a vertical line representing all of the points that are at negative 2, where x is negative 2. And then I'm going to dash that because it's not equal to dash, 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 dash. And again, thinking of this 0, 0 point here, 0, 0, is that part of the solution? Is 0, 0 part of the solution? The question being, we are going to check if 0, 0 is part of the solution. And then the question is 0 less than negative 2? Is 0 less than negative 2? No, it's not. So that's not part of the solution. Therefore, everything on the other side of this barrier is part of the solution. So any point that I choose over here would be part of the solution. And we could just pick a point over here, and any point that I pick, so that'd be negative 1, 2, 3, 4, 5, negative 5.5, negative 5.5, and then what's it at negative 2y. And all I need for that point to satisfy the solution, or satisfy the inequality, is the x value less than negative 2. Well, looking right there, yes, the x value is less than negative 2. It's negative 5.5. So that is a solution. If I pick a point over here, that point there is at 2, 2. Is x for that point, is x less than negative 2? Is x less than negative 2? No, it's not. So if you just slow down and even look at a point or a couple of points, you can be sure that you're keeping the sense of things and representing the solution correctly on these problems. So those are two examples of finding the solution to the inequality. Now I want to take a look at finding the inequality. So given the region or given the solution, what inequality did that come from? So here's an example here of a region that we've been given. And what I need to do is figure out what is the region in which that occurs. Well, if I look at this edge here, that's what I need. I need to know where is that edge. It's a line, obviously. And lines, I think that most students think of lines in terms of y equals mx plus b. There are other ways to think about it, but if we can think about it in that way, we will. And here, I've got y equals, and let's see if we can find the slope here. There's a point there that is clearly identified at negative 2. And I want to go up to another clearly identified point, which seems to be this point here at 1, 1. So let's take those 2 points there. I got that point at 1, 1, and I've got this point at 0, negative 2. So with that, I can say that my slope is up 1, 2, 3, and over 1. 3 over 1. So I'll just write that as 3 for the slope. X plus, well, of course, we know that b is the y-intercept. So I'm going to go plus negative 2. And of course, I'll just write that as minus 2. Get in there and put a minus. So 3x minus 2 is where that edge is at. And then the question is, do I want to say, what do I want to do with my inequality to get a result that would give me all of these values over here, that any of these values here would satisfy the inequality? Well, I think if you I guess what we could do the 0, 0 method again, and we could say, how would we use the origin? I mean, is the origin part of the solution? No. So I would want to shade away from that. And what values would be away from that? Well, it looks like if I think about this as this 0, 0 is up here, then I want to be down here, down from 0. So what would down from 0 be as far as the y variable mean? Down from 0 would be y is less than 3x minus 2. And then we can check that, right? So I can go, and notice also, we keep coming up with less than or greater than signs, and we're not getting the equal to sign on these. So just remember that we could get an equal to, but we keep getting less than or greater than, so these are all being dashed. So it's a dashed line that goes along with the less than or greater than, and we're not getting the equal to sign in there at all. All right, so back to the idea of checking this. I want to check, and I'm going to check with 0, 0. And if you look at the graph, we see here that 0, 0, the origin, is not shaded, so that is not part of the solution. And when I plug it in, I should get an untrue statement. I should get a false statement. So I'm going to put in a 0 is less than, and I'll just go like that. 0 is less than negative 2 because the x is going to 0 out and the y is going to 0 out, right? So 0 is less than negative 2. Is that true, true, or false? And of course, 0 is not. That's false. So 0, 0 is not part of the solution. And the way that it's graphed, it's not. So we do have the correct inequality, provided everything else is correct. So that is our solution there. That's the inequality that satisfies that picture. And let's just look at one more. Here is again a vertical or horizontal line that students sometimes have trouble with. We saw in the previous one that the vertical line was x. So in this case, I've got x, and where's that happening? At -5. So if I said x is equal to -5, that would be this vertical line. And then what's the inequality? Well, clearly I'm to the right of that, so that is going to have to be greater than. We want values of x that are greater than -5. And here finally we have a solid line, so this is where we need to do the equal to. X is greater than or equal to -5. So those are cases of finding inequalities, and prior to that we had the cases of finding the solution to an inequality, and we want to be able to do both of those moving forward.